This app scores a flight from Lakebase Postgres in milliseconds. Watch. Almost a second? Exactly. It was supposed to take a second or two because it was sleeping. Lakebase is Databricks' managed Postgres, and it can scale to 0 where it's sleeping. And that means if you're not using it, you're paying $0 in compute. Since it just woke up from its nap, let's run this again. 8 milliseconds. It's fast when you need it, basically free when you don't. Hey everybody, Ryan Chichak. And the reason it sleeps and snaps back this fast is one config block that I'll show you. But first, the weirdest thing in this data is the Seattle departures. Let me dive in. If you look at this map, you can see it's 20 years of US domestic flight data from 1988 to 2007. And this is also including weather data from NOAA at each of these airports over that same time. So the question that this app answers is which flights run late, and then what's the weather doing when they take off, when those flights take off from the origin airports. Let's zoom into one of these origin airports we just looked at, and that is Seattle. And you can see from this color that the flights delayed more than 15 minutes, 35% of the time are closer to red and 0% are green. And if you look at Seattle and Chicago, ORD, they're roughly the same delayed. As you can see, 20% versus 22%. And all of this is pulling live from Lakebase. As you see, 8 milliseconds lookup time, which is very fast, as I was talking about in the beginning. And then if you look at the bubbles of each of these airports, the size of the bubble is roughly how busy the airport is. How many departure flights are put out of each airport? So if I look, you can see in 1995, there were almost 300,000 flights out of Chicago, whereas the bubble smaller in Seattle, there was roughly 90,000 flights in 1995 for Seattle. And all 20 years live here. And let's just drag this slider at the bottom. You can see I can play each of these years, and here's 96. And you can see over this period of time, we are increasing the number of flights in Seattle. And you can see that going up from year to year. But you see how quick this is pulling live from Databricks. And this is really just one lookup, and it provides the whole picture. And it's not just one click. You can click in and then you look at the whole picture of how the airport runs, how the airline runs, the routes, plus the weather of that year. And then what we can do is we can actually slide this to look at a color representation of snowy days. And you see Chicago has a lot of snow, but the origin city of Seattle does not have much snow. And if we look, though, at the storms, which include thunder and fog, there are a lot of days of thunder and fog in Seattle. And then if I score this again, 8 milliseconds. And I can score multiple years if I want. And then this is going to compare those years. And then that way we get a visual representation all in one query. That is the feature store of Feast in this case. And then if we want to look at what the worst route is in 20 years, that is from Philadelphia to Oregon. And if we zoom into the map here, if I go into Philadelphia, set that as the origin, and then we set the destination, Portland, I should say. And then that was 2007. you can see just how bad this was. The delay was almost 40% of the time. And if you look at another route that is an infamous one, Chicago to LAX, so ORD to LAX, and you can see that's 29% of the time. And what you see here is that how quick this is to look this data up. It's almost instantaneous from Databricks Lakebase. And really, if you look at the architecture, which you can click up here, you can see that Feast is the feature store. And 20 years on about 4 tables in Feast is a very small amount of data, but it's very, very fast. And you're able to plug in Databricks Lakebase with just a single block of code, and you don't have to use Redis. You don't have to use Cassandra or DynamoDB or Bigtable. It's easy to just use Lakebase and get that scale to 0. And really the simplicity of this and then the speed is being able to run this app in the same region as the database, which is Lakebase in this case. So it's US West 2 in my case. And this is something that I can show you is if I have that cold start in the beginning, which was about a second, if you remember, and you can see here is my active Lakebase running right now. If I take this same app and I run it on my laptop and I'm in Chicago, I'm going to add a lot of latency because I'm pulling from US West 2 on the West Coast. And you're going to see that. So this is taking 5 milliseconds but if I run this, let's say on my laptop, as I said, and let's say I pick LAX as an origin, and let's say I pick Minneapolis as the destination, it takes 81 milliseconds. So you really have to, locality is very important. And scale to 0 is one setting. And let me just show you how simple it is to do that. So you pay $0 for compute. All you have to do is just go into your compute and then scale to 0 after the amount of time. Right now I have 21 minutes. If I set it to 1 minute, it's going to scale to 0. And then again, we're paying $0 for compute. So the thing is I want you to remember today is one block of config for this managed Postgres, which is Lakebase, is answering in milliseconds and dropping to $0 to compute the moment you're done. And then I guess the question that I have for everyone is, would you run your feature store on Postgres, or do you like Redis? Do you like all the different Cassandra and the different ones, DynamoDB, that are available today? Excited to hear in the comments. Thanks, everybody.